The serial peripheral interface. Or the SPI, is a device that separates the data line and the clock line of microcontrollers. This is useful when the microcontroller needs to communicate with sensors, external shift registers or SD cards. Some devices will utilize a select line to select the peripheral it needs to communicate with. The sender becomes the master, and it controls the rate at which data will be transferred, while as the device being spoken to or receiving the data will become the slave. In essence, you've got the SPI master that consists of a clock, the master out, slave in, the master in, slave out, as well as the slave select pins. We will also have our receiver, which we call our slave, SPI slave. Also has a clock, as the master out, serial in, or slave in, master in, slave out, and then it has the slave select. The clock feeds from the master to the slave. The master is in control of the clock. Then the master out, slave in is the data transfer that goes from the master to the slave. Then there is a master in, slave out that is used for communication, to indicate to the master that the slave is ready to receive data, or the line is open for receiving, or maybe for some feedback information. And then the slave select, when it is high, the slave does not listen to the master, but the moment the slave puts that on low, then it activates the slave over there, and that will then indicate to the slave that it has to receive data. On the slide we can see the basic operation on how the clock pulses, or the pins on the master and the slave, communicate together in order to transmit and receive data between the two. The microcontroller in the serial peripheral interface will become the master in the communication. The peripheral device will become the slave, as it is controlled by the master. And by the peripheral device we mean the sensor or the flash memory stick or something along those lines. For the purpose of slave devices, the communication is exactly the same, with only difference in communication that occurs between the master as a single slave. The slide shows the serial peripheral interface, independent slaves, whereby we've got one master that controls 3 slaves. Take note that we've got slave select 1, 2 and 3, each connected to the individual slave modules on the right hand side. The data being transmitted and received by the master goes to and from all the slaves at the same time. However, only the slave who's selected by putting a low on the slave select will be receiving or communicating with the master at that moment in time. The slide shows the serial peripheral interface daisy chain, whereby we've got the master on the left that is sending information to the first slave on the right hand side. The first slave then sends information via its master in slave out to the second slave's master out slave in pin. This type of communication is slower because the data moves from the master to one slave, to the second slave, to the third slave, and then any feedback has to follow that same route before it can come back to the master in slave out pin on the master.